Welcome to massive open online course on cartographic techniques practical. This session is about conversion and construction of graphical scale and representative fraction on the continuation of the broad topic map scale. Okay. This session will be having the following concept. One is meaning of graphic scale, and we will be constructing the graphical scale from the representative fraction value given in the bottom of map scale, and we will convert the graphical scale into representative fraction. Finally, we will discuss about the other type of graphical scale other than plane scale, like diagonal scale, comparative scale, time scale. Okay. Now, let me explain the meaning of graphic scale. Graphic scale is the visual representation of map scale in the form of straight line, and that will have some divisions. As you see in the screen, see this is a graphic scale given in the Indian topographical sheet. This is a part of OpenStreetMap download from online survey of India. You can also download. This is a graphic scale and this is representative fraction. We discussed about this in previous class, and this is statement type of class. So, either from representative fraction of class or statement type of class, we need to construct this graphic scale. This is the main theme of this class, okay, this session. Okay. See, observe this scale carefully. There are some divisions from this to this one division, here to here one division, and here to here one division. These are called as primary division. So, graphic scale has some division. First is primary, these are called primary divisions. Okay. Next, left side to the 0, there are other divisions, smaller divisions. Okay. Okay. These divisions are called as secondary divisions. Okay. Small divisions, secondary divisions. So, graphic scale is about visual representation of map scale containing primary divisions and secondary division. Okay. As of now, this much enough, and these are present almost in all the general purpose map like topographic map, atlas map, wall map, thematic map. Okay. Right. This is the meaning of graphic scale. Now, let us discuss about the key advantages of this graphic scale. As you see in the screen, this helps for direct measurement of the scale. How means, you look at the screen, here is the graphic scale. Okay. From 0 to any value, here is the 0 and here is one value and here is one value. Okay. In between two values, you can measure the distance using any scale, like this scale you can use, and you can measure the distance between 2 points. Okay. Let us think the distance between 0 and this point 1 centimeter. Okay. And there is some value written, that is 46. Okay. This means 1 centimeter on scale represent 46 centimeter or kilometer on the ground, but here there is no written any unit value kilometer, or means 1 centimeter on the scale represent 46 kilometer on the ground. This is the meaning. Okay. Here direct measurement, we need to measure directly using the scale, we can understand. Okay. Next, this scale, the best advantage of this scale is it will be accurate even if the map is zoomed out or zoomed in. If we enlarge the map or reduce the size of map, I mean when you work with the digital cartographic software like ArcGIS or QGIS, you will be enlarging and reducing the size often. So, in that case, after enlarging or reduction the size of map, you do not want to draw a map again, you do not want to delete the previous map. Automatically, as per the enlarged size or reduced size of a map, the scale size will also be increased or reduced. So, that is the I mean one most important advantage of this scale. Okay. When you take the statement scale or other type of scale, you need to delete and you need to insert again. Okay. Third important point, it is intuitive for understanding of distance for map users. It will be easy for common people, lay student or other department student to understand the map scale easily. Okay. Next, let us discuss about how to construct a graphic scale from the value given in the form of representative fraction or statement scale. Okay. Before constructing, there are some steps, easy steps. After 1 minute, I will be showing you how to construct. First step is identify the given scale. I mean, every map will be having the scale in the bottom, no doubt. Okay. The scale may be given in the form of statement or representative fraction like 1:50 or 1:1 lakh, however. Okay. Now, whether the given scale which wants to be converted is in the form of representative fraction or statement type, we need to identify. Okay. Second is select the ground distance. See the graphic scale with the help of one drawn scale, bar scale. Okay. So, bar scale should have one length, and that length, the total length of bar scale will represent a particular unit of length on the ground, real world. So, how much unit of length we are going to represent in the ground, maybe 5 kilometer or 10 kilometer, as per our own choice we can decide that. That is the second step. Third step, as you see in the screen, calculate the scale length. After choosing the ground length, we can fix the scale length. Okay. For example, if 1 centimeter is going to represent 1 kilometer, if we want to represent 5 kilometer on the ground in the scale, okay, then here we can draw 5 centimeter length full scale. Okay. So, we want to decide the scale of length after choosing the ground length. Final step is, after having the length of scale and choosing the ground distance, we can draw the scale, bar scale, okay, by having the 0 point and by having some primary divisions and by having some smaller secondary divisions. Okay. Let us construct now. Now, for example, look at screen everyone. Okay. Here we are going to construct a graphical scale using this representative fraction scale. Here given value is 1:50,000. See, representative fraction is common for any system of measurement, that may be a metric system or that may be a English system, that is inches to mile. This is English system of measurement. This is metric system of measurement, you know. Okay. Yes. Now let us consider this is given in the metric system. I mean 1 centimeter is equal to 50,000 centimeter. Okay. This is numerator represent the map distance. 1 centimeter in map represent 50,000 centimeter on ground. This is the meaning. Okay. Now, we identified the scale. Next, we need to choose the unit of length we are going to represent on the ground as per our own choice. It is according to our wish. Here I have chosen 5 kilometer. I want to represent 5 kilometer of length on the ground using this scale. Okay. Third step is, now I need to calculate the scale length. See, I am going to represent 5 kilometer. 5 kilometer means 5 lakh centimeter. You know, 1 kilometer in previous session we have discussed different system of measurements. 1 centimeter is equal to how many millimeter, how many centimeter is equal to how many meter. So, 1 kilometer is equal to 1 lakh centimeter we have discussed. 5 kilometer is equal to 5 lakh centimeter on the ground. Okay. Now, our chosen ground distance is 5 lakh centimeter. Our scale denominator is 50,000 centimeter. If we divide both the value, I mean 5 lakh centimeter divided by 50,000 centimeter, we will get 10 centimeter. So, this is the length of scale. So, to decide the length of scale, we need to divide the ground distance by scale denominator, we will get the total length of the scale. Okay, let us construct. Now, we want to draw 10 centimeter by line. I am drawing by rough, but you draw 10 centimeter line. One more line for better understanding, let me draw one more line, 10 centimeter line. Let me have this as A point, this as B point. Okay. Now, for better understanding, I want to divide this into 5 major divisions. First, let me explain in systematic way, but then I will say the shortcut also. Okay. Here 10 centimeter total centimeters are there. Okay. I want to, as per my wish, I want to divide this 10 centimeter into 5 broad divisions, okay, with equal distance. The systematic way to divide this length 10 centimeter length equal 5 parts, you can take protractor, you know, some geometrical instruments are there, devices are there, protractor will be having angles. Okay. Have a protractor, look at the screen, you can keep the protractor like that, you know, protractor will be like this. Okay. And you can mark any angle less than right angle. Let me take 30 degree or 45 degree, less than 90, any angle you can take and mark. Okay. After taking the protractor, you can draw one straight line by connecting the point you marked with the 45 degree or 30 degree angle and the point A, like this I am drawing. You can draw like this. Then next step, you can take a divider, you know, another one geometrical instrument is there, divider is there. Using the divider, you can fix equal value, maybe 1 centimeter or 0.5 centimeter. Without measuring, you can take a particular length of measurement and you can divide this line drawn in the particular angle. Maybe this is going to be your first divide, then you mark your second divide with here, and third divide, fourth divide, fifth divide, and we need only 5 divisions in this scale. Now, we need to connect this. So, let me select another color. We need to connect the last point in the angle line and B line, this line and this one I am drawing. So, I connected the last point in the angle line and B line. Then using the scale, we need to draw a parallel line to this, parallel line to this. Next line, maybe we can keep moving the plane scale and we can mark the point, maybe like this, like this, like this and like this, right. Here the first point can be marked as 0. Right portion of the scale next to 0 will be having primary divisions. We can write the value later, but mark the divisions like this. Okay. Now, if you measure the scale, plane scale again, if you keep approximately this scale will be having 2 centimeter length, I hope. A shortcut, if I want to say, another one way to divide this 10 centimeter into 5 equal parts, you know, because anyhow we are going to take a round number for a map and ground distance. So, now I explained the systematic way. The shortcut easiest way is, you know, 10 centimeter can be divided into 5 divisions using 2 centimeter, because 10 divided by 2 is 2. So, from 0 next to 2 centimeter we can mark one point, in 4 centimeter one point, 6 centimeter one point, 8 centimeter one point. Left hand side, left portion of the scale, left portion to the 0, there will be definitely remaining 2 centimeter. There you can mark secondary divisions later. Now, you can easily mark the value. I mean map distance you have marked graphically in the scale. Now, you want to mark the ground distance on the scale. Okay. Now, as per the RF given in the example, if 1 centimeter represent 50,000 meter, here 2 centimeter we have. 2 centimeter will represent how many centimeter? 1 lakh centimeter, right. So, 1 lakh centimeter is nothing but 1 kilometer. So, here in graphic scale we have 2 centimeter length, that is why the first division may be marked with 1 means 1 kilometer, because 2 centimeter is equal to 1 lakh centimeter, 1 lakh centimeter is equal to 1 kilometer. Then next division will be 2, here 3, 4, 4 means 4 kilometer, right, we marked, right. Next, left portion of the scale, left portion to the 0 point in the scale should be marked with the secondary divisions, right. Now, which is the immediate lower unit to the kilometer? Hectometer. I mean 1 hectometer is equal to 1 hectometer is equal to 100 meter, you know. 100 meters will be 1 kilometer. So, here it should be the left portion of the scale to the 0 should be divided into 10 equal parts. First, let us divide the scale into 10 equal parts, then we will write what we want to be write, we will decide later. Okay. First systematic way, as we drawn the angle scale earlier to divide the main bar into 5 equal parts, either you can follow that way or easily you can divide this 2 centimeter into 10 parts. 2 centimeter will have how many millimeter? 20 millimeter into 20 millimeter is equal to 2 centimeter. If you divide by 10, one value, one division will be having 2 millimeter. For every 2 millimeter, you can have one division. Let me select another line, another color. Okay. So, either you can, for every 2 millimeter, you can draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this. Or another way, you can keep angle using protractor, and you can draw a straight line using that. You can divide 10 divisions in that line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this 10th line and 0 point can be connected. Then you can draw a parallel line to that 0 line. You will get same division anyhow. But that is a systematic way. But usually the cartographer, map maker will select a round number for total length of scale, and using the value, by calculating the value, we will mark the divisions. Okay. Now, there are 10 secondary divisions are marked in the scale. Okay. Now, each division will represent 1 by 10th of 1 by 10th value of main division, right. The main division value here represent 1 kilometer, right. What is the 1 by 10th value of 1 kilometer? 100 meter. So, we can either write first division is 100 meter, next division is 200 meter, 300, 400, 500, like that we can go on, or usually we will use the term hectometer. 1 hectometer is equal to 100 meter. So, here also we will write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Finally, here we will write 10 hectometer. Hectometer means 100 meter. So, this is about construction of graphic scale. Okay. The graphic scale has 3 main components. One is 0 point. After fixing the total length of scale, we need to mark the 0 point. From left side after the first division, we have to mark the 0 point. Right portion of the scale, right portion to the 0 in the scale should have primary division, left portion of the scale should have secondary division. This is the thing. The left portion of the scale will be representing 1/10th value of main division of the scale. Okay. These are the thing you want to keep it in mind. Now, we have constructed the graphical scale using the representative fraction value. The next example is in English system. English system is all about inches to mile, inches, feet, yard, furlong, then mile, you know, right. As this is the core theme of today's session, let me spend one more minute on this also in faster way. Okay. Here look at the screen. Here given problem is 1 inch represent 1 mile. So, first we are finding the given scale. Given scale is in English system because it is about inch and mile. Okay. We want to convert this scale in graphic. Okay. Now, we will represent 6 mile. Okay. Let us represent 6 miles on the ground. Okay. If we want to represent the 6 miles on the ground, what we want to do? The length of scale should be 6 inches because 1 inch is in representing 1 mile. So, let me draw 6 inch scale. I am drawing as I have explained detail in earlier slide with earlier slide. Let me go a little faster. Okay. So, I want to draw 6 divisions 1, 2, 3, 4, 5. Okay. Now, 6 divisions are there 1, 2, 3, 4, 5, 6. Okay. After first division, I want to mark a 0 point, right. Now, next right portion will be representing primary divisions, that is mile. 1 inch, I mean usually the distance between 2 points here, if you measure by the scale, it will be graphically in true, it will be giving 1 inch of distance. That is the speciality of graphic scale, direct measurement. Using the scale, there is a inch value also in scale, you know. So, if you measure the distance between first in between any 2 primary division, the distance will be 1 inch. Okay, you have marked. How to mark? We explained, we discussed in earlier slide. So, here 1 mile, 2 mile, 3 mile, 4 mile, 5 mile. So, these are representing miles. Now, left portion of the scale, left portion to the 0 should be representing secondary divisions. Here the left portion should be having 8 divisions. In English system usually we will have 10 divisions, but here only 8 division. Why? Because next immediate lower unit to the mile is furlong. 8 furlong is 1 mile. So, here primary division is denoting mile. So, the secondary division should be denoting next immediate lower unit, that is furlong. There are 8 furlongs in mile. So, the secondary division should have 8 division. So, 1, 2, 3, 4, for my comfortability I am drawing again 6, 7, 8, 5, 6, 7, 8, 8 furlongs. Okay. We have drawn the graphic scale in English system from representative fraction. So, we constructed graphic scale. I hope you understood. Okay. Next, converting graphic scale into representative fraction, very easy. The value will be given in graphic format. You need to convert that into representative fraction format like this, from this to this. What are the steps here? We need to first measure the scale and find the ground distance and map distance. Next, we need to convert and calculate the representative fraction. Let us calculate for one. Now, look at this scale. The problem, I mean the map scale is given in graphical type. Okay. Now, look at this problem, look at this screen. Okay. Here the scale is given in graphical format. We need to convert representative scale from this graphic scale. Okay. Representative fraction is all about the ratio between map distance and ground distance, you know. So, what is the map distance you want to find? Then you have to find ground distance for calculating representative fraction. Okay. Here representative fraction is divided by ground distance. This is nothing but representative fraction. Okay. Now, to find the map distance, you need to use a real time plane scale and you should measure the distance between point 0 to 1. For example, let me keep this as a 2 centimeter. I only prepared because I know. So, here the actual distance between 0 and first point is 2 centimeter. So, let me keep 2 centimeter is the map distance. Ground distance we do not want to worry, already it is written on the scale, above scale 1, 2, 3 like that. Okay. Now, 2 centimeter represent 1 kilometer. This is the value we got. Another final point, simply always the representative fraction will denote 1 centimeter or 1 inch on map distance. So, we need to, if 2 centimeter representing 1 kilometer, 1 centimeter will represent how many kilometer? 0.5 kilometer. 0.5 kilometer is equal to 50,000 centimeter. See, in representative fraction, two things we need to keep it in mind. Both numerator and denominator should be in same units. Numerator in centimeter, denominator in kilometer should not be. Right. So, that is why we converted 0.5 kilometer in centimeter. So, this is the answer. Representative fraction is here is 1:50. Finally, the representative fraction will not have any unit of measurement. It will not be showing kilometer, centimeter, inches, mile, no. It will be having only numbers. So, the answer for given problem is 1:50,000. Right. Okay. Now, the final concept of this session is types of graphical scale. First one is plane linear scale. We discussed about this, how to construct this plane linear scale from RF and statement type we discussed. Usually, this type of scale will be used by all the general cartographer, all the thematic map makers. Next major type of scale is comparative graphic scale. You look at the screen, comparative is nothing but it will have two graphic scale. One graphic scale will be representing English system, another graphic scale will be denoting metric system. See, there are two scales, both are having 0 point, okay, both are having primary points, both are having secondary points, okay, but one scale is in metric system, another scale is in English system. Right. Why? Some international maps, travel guide maps will be having this type of comparative maps, because some common people will not be aware with the metric system, some people may be much familiar with the English system. That is why comparative scale is also used sometime in the bottom of map. Next type of scale is diagonal scale. Usually this type of scale is used by engineers while making cadastral map, village maps. Village administrative officers will be having maps. Okay. Those maps may have this diagonal scale. Okay. Not compulsory, but engineers and village maps are having this type of diagonal scale. Simply, it is also a graphical scale. The only difference between plane linear scale and this diagonal scale is the plane scale will represent only 2 units. Example, if it is in English system, it will represent only kilometer and hectometer. I mean, primary divisions will be showing 1 kilometer, 2 2 kilometer, like that means the secondary divisions will be showing hectometer, 100 meter, 200 meter, like that. This diagonal scale, in the same case, if we apply the primary divisions, right portion of the scale, this, if this is representing kilometer, the secondary divisions will be explaining hectometer. Hectometer means 100 meter. Okay. Then tertiary division means this one, from this point to this point, this point to this point. This will be representing decameter. Decameter means what? 1 decameter is equal to 10 meter. So, here 1 kilometer means 1000 meter, hectometer next immediate lower unit to the kilometer, that is 100 meter. Okay. 100 meter is called hectometer. Then decameter means next immediate lower unit, that is 10 meter, decameter. So, diagonal scale will represent 3 units, but plane scale will represent only 2 units. This is the difference. Okay. Construction way, one point about construction way of this diagonal scale. Way of constructing diagonal scale is similar to plane scale. First we need to mark 0, then we have to mark primary points, then secondary point. Additionally, the third one, we have to mark 10 additional divisions. In upper way we have to mark, maybe if this is the center point, first line will be this one. Okay. This is the first step. You will mark 0, then you will mark primary divisions, then you will have secondary division up to this. Then in upper side you can mark 5 division, in lower portion you can mark 5 division, totally it will be the 10, 5 plus 5, 10 divisions. Here you can mark decameter. Okay. You will be studying about this scale, diagonal scale, maybe in post graduation. Okay. Next, about time scale. Look at the screen. Usually the map will have spatial distance. The map scale, either the plane scale or diagonal scale or representative fraction, will be denoting the spatial distance, ratio between the map distance and ground distance, all about the spatial distance. But time scale, as you see in the screen, will represent the time, travel time between one place to another place. Here the scale will be mentioning the time. To understand the time scale, you know better, if you are traveling in the bus or car or in bike, what is the speed of vehicle? If your friend is asking, you will be saying the speed is equal to 50 kilometer. My bike is going in 50 kilometer speed, means speed is equal to distance by time. Okay. Now, if we want to calculate the time value of the particular spatial distance, then here hour will be going this side, time will be obtained by dividing the value of distance, here 50 kilometer, and the speed. I mean, time is equal to distance by speed. This is the formula. Okay. So, to find the time limit, in how many hours or how many minutes we can travel from this place to that place, if we want to calculate the time limit, we want to know the distance between those 2 points, and the standard speed limit can be traveled in that road should be known, because bypass road, in bypass road if we travel, usually we can travel in the speed of 80 kilometer. If we travel in the village road, we can travel only in the speed of 30 kilometer per hour. So, first we need to fix the speed limit for all the types of road for which we need to prepare time scale, then we can mention the time, travel time in all the roads. Usually this time scale are mentioned in the travel network maps, okay, for the help of travelers. Some common mistakes we need to avoid while preparing this graphic scale, that is unit conversion should be taken care much, and we should not have more divisions in primary and secondary divisions. More than 5 primary division will not be neat, more than 10 secondary division will also not be neat. While placing 0, we should be very careful. The first division of the scale should be marked as 0. Then inconsistent scale across map. For example, if you are doing a research, you will be making more than 50 maps, okay, thematic map, study area map, many maps you will be preparing. So all the maps should have a same scale, same ratio of scale. One map is having large scale, one map is reduced into small scale, it will not be nice, okay. Now, so key takeaway from this session, I want to say you, graphic scale helps you for direct measurement, and it is will remain accurate after enlargement and reduction, right. And we have different graphical scale types used for various purpose. For example, diagonal scale is used for engineers for preparing village maps, even building plan, etc. And it can be converted from graphic form to representative form and statement form. This is all about this session. Thank you very much.